Hey, what's up guys, my name is Cherno and welcome to the 4th episode of reviewing my Ludum game that I made ages ago called Genesis. So, last time, and I know it's been a while since the last episode, and I'm not going to get into wasting time talking about why and stuff, you know why, it's me. Anyway, so today we're going to basically move on to what I promised we'd move on to last time, and that is the lighting and how that works and all of that stuff. So, by lighting, of course, I'm referring to the fact that we're going to basically overview the entire lighting engine, if you can call it that. It's very simple, and we'll talk about how it works and how it doesn't work as well, because there is a bug with it that we need to fix. And I mean, I have not done any overview of this lighting end. Like, I haven't looked at the code at all, right? What you see in these videos is the extent of my exposure to all of this code, right? Since I wrote it. Like, since back then, right? So, I mean, I haven't done my homework on this at all. So because of that, the nature of these videos is going to be quite live, as you know. And also, it kind of gives you, I guess, an insight onto how I kind of work out how certain code works, right? So, I mean, right now, in this point in time, I have no idea how it works at all. Okay? I have no idea. I mean, I remember certain pieces here and there, but I mean, I couldn't tell you what class it's in even. Like, I don't know how it works at all. Okay, so I think that creates kind of like a unique thing. I mean, I just don't have the time to obviously go through all this and look at my own code that I've written ages ago and work this out, unfortunately. But I think on the other hand, like, whilst that would lead to probably more concise and better, you know, quality videos, this also gives you the other kind of perspective, which I think is quite unique and cool. So anyway, and I'm also going to, and also I have no idea why the bug that is happening, okay? I still don't know. I know it's been 4 years and I still don't know why that bug is happening, okay? So today, whilst we're not going to prioritize fixing it or anything, because of course we're going to just overview all of the code for the game first, and then we'll move on to like creating a to-do list and fixing everything. I think I've already created some to-dos actually. If we go to window, I think show view and then tasks, then maybe, yeah, so to do, we've got this cache this thing for the font stuff, so potentially something excuse me, I'm a little sick as well. I'm a little kind of sick-ish as well, so just bear with me if I start like coughing or whatever. Anyway, so the idea is we'll kind of, you know, we'll do this, we'll go through the code first, then we'll work out how to fix it and stuff like that. But I will be keeping my eye out on actually on why that bug is happening. So as I go through the lighting code, I'll be just in the back of my mind, I'll be like, could that be causing it? What's going on? So anyway, let's excuse me, let's take a look at what I mean by lighting. One thing we are going to do, or try to do, is go into the level class here and actually see if it might be possible to increase the day-night cycle. So this game has a day-night cycle, in which I guess the brightness dictates whether it's day or night. Yeah, exactly. So if the brightness is greater than 20, it's day. If the brightness is less than -200, it is night. Okay? Obviously, the speed at which the brightness kind of goes is, I guess, brightness plus, maybe. That doesn't make any sense because, okay, if it's day, if it's night, okay, so this should never this should never be hit, basically. But we have basically the speed of the brightness here. I think the time method, which is really what does everything, yes, is dictated by this kind of, this is how often it runs. So if we were to, like, you know, decrease this or something to about 10, it should be a lot faster, the day-night cycle, 5 times faster, in fact, which might not even be fast enough. So let's just basically get rid of it. If we do something like that, then you can see how fast that day-night cycle is. That might be a little too fast. I might make it 4. Okay? And let's get into it good. Okay, so what we have here is basically the day-night cycle and the lighting of this game. So things you can notice. First of all, brightness decreases of everything, except for where we have these torches, in which case they emit light. Now, from what I can remember, it's very simple as to how it works. I'm going to actually take a screenshot of this real quick and maybe boot up Paint. Not even Paint.net, apparently, just Paint. So we can kind of decipher this, and because you can see it's already going the other way. So we'll keep that running in the background, but we'll just take a look at this. Okay, so what we have here is essentially you can see that the areas that have the torch, right? The brightness of the adjacent tiles to that torch is kind of dependent on the distance that it is from that actual torch, right? So more or less some kind of diagonal distance here. Not distance in terms of tiles, like Manhattan distance or anything. It actually just looks like, you know, kind of as the crow flies kind of distance, a direct distance, right? I've forgotten the name for it. A Euclidean distance, I think is what it's called. it's a Euclidean distance rather than a Manhattan distance, of course, and then that kind of dictates the brightness of the tile. So you get this kind of interesting thing where obviously diagonally we have to travel a further distance, which is why this tile is roughly the same kind of brightness as this tile, and then this tile, and then this tile. And we kind of get a nice effect where we kind of get, you know, we don't get like smooth lighting in the sense that it's not completely smooth. It's actually kind of restricted to tiles. As in, tiles have a brightness value associated with them, and that brightness value is the brightness value of that tile. There cannot be such thing as like a tile having multiple brightness values or a tile having a gradient of brightness, right? A tile is a constant brightness, has a constant brightness value, and that dictates how bright the tile is, and that's that, right? Which is why you can see that each tile basically has one color associated with it, right? It's in no way kind of a gradient or anything like that. It's basically flat. And that of course is just a stylistic kind of aesthetical choice that I've made, because I think it looks a lot cooler, especially with a game that's kind of low resolution. You can see that, like, obviously these characters, and man, paint is really terrible. But anyway, you can see all of these kind of characters here are obviously low resolution. This water isn't particularly cutting edge. I just realized the music is going through all of this. I hope you guys can hear me all right. Yeah, you'll be fine. Anyway, I mean, it's kind of low. It's kind of like a low kind of poly, I would call it, game. I don't know, like a lo-fi kind of game, obviously pixely. So this kind of, I decided to make the lighting like this because I think it would suit it quite well. Anyway, that's how that works, okay? So in terms of brightnesses, it's very simple. Lighting should work in a very simple way. This is I'm not talking about entities right now, just about the actual level and against the actual terrain and everything and these tiles. So you can see that, like, essentially, just to summarize that, the distance, the Euclidean distance from the light source is what, or rather the brightness of any given tile is determined by its Euclidean distance away from a light source, okay? Very simple. Yeah, I mean, that's how lighting works, right? I mean, in real life, the further away you are from a light, the dimmer that surface is going to be lit, right? Now, when we have surfaces which collide like this, I actually don't remember how I handled that. I think it actually isn't additive. I think it's actually... So let's find two torches that are really close together, if that even exists. These two might be... Yeah, you can see... Okay, so this is interesting. Because it looks like these are actually darker than if they were by them. Yeah, you can see that the way the lighting works here is that it looks like it might be multiplying the values together or something like that, because this results in being a darker tile, even though you would expect it to be brighter because there are two lights, okay? So instead of being additive, it looks like it is actually being, you know, some kind of multiplier or a scalar. So that's probably wrong as well. And I don't know if we want to fix that, because that might not necessarily, you know, manifest itself as a, whoops, sorry microphone, as a bug per se, but I kind of don't like it, so maybe we'll have a go at fixing that and I'll add that to my to-do list. Okay. So anyway, sorry if I seem like I'm talking a little bit fast. It's not because like I'm hyped up on speed or coffee or anything like that. It's because I know that these videos are going to get out of control really quickly as far as time goes, so I'm trying to be as concise, but also I have a lot on my mind. So anyway, you might want to watch this video at half speed if you really want to. Don't do that. Okay, so that's the way that cookie crumbles. There's that phrase again that I should stop saying. Yeah, here we go. Exhibit A, lighting bug. You can see that the player is still kind of lit. So now we'll move on to entity lighting. This entity is still lit, even though he's far away from the light, okay? That's wrong. And like the way that entity lighting is supposed to work, and you can see these aren't lit at all, even though they kind of stepped into the light there. The way that entity lighting is supposed to work is that there is no kind of flat, I guess, flat approach to entity lighting, right? It's just like your distance, your Euclidean distance from. I really hope Euclidean distance is the right term because I've been saying it all over the place. Let me just Google that. I'm like 90% sure it is, but my mind is like, where is my mind right now? Yes, so straight line distance or Euclidean distance. Just double checking, that's all. Like literally your kind of straight line Euclidean distance away from an entity to a light source is the brightness of that entity, okay? But for some reason you can see, yeah, so see, it's working right now, yeah? Like you can see I kind of fade in smoothly and then I fade out smoothly as well when I leave the light source. It's just sometimes it doesn't work for some reason, and that's the bug, because you can see like, yeah, like it's not even smooth now, and you can see that it looks like I've went into the light, it's increased my brightness, then I've moved out of the light and the brightness has remained. Okay, so I think there's something very fishy going on with that, and you can see like some of these entities are just various brightnesses. It's almost like they've frozen at a particular incorrect brightness level instead of actually, yeah, see, now it's kind of working. So it's one of those bugs that unfortunately doesn't happen all the time. I'm sure if I actually read the code, I'd be like, well, yeah, well, this is stupid. This is why it's happening. So it might be really simple to solve. It might not be. Again, you guys are welcome to like pause this video, look at the code yourself and figure out why it's going to happen. I don't know yet if I actually find the reason in this video. So maybe we'll find it and we'll be like, okay, we'll write a note being like, you need to fix this. And this is the reason why it's happening. Or we might not, or we might be like, this is a bit tougher than we thought. So we'll see. Okay, cool. Anyway, that's how the lighting actually works. Now let's look at the code. So from memory, the level render function, of course, the render method inside the level class is where all of the tiles get rendered. Therefore, the lighting has to occur there somewhere because that's where the actual pixels from the texture get put onto the screen. From the tiles texture get put onto the screen. Where does that actually happen? So let's go through this code roughly and I'll kind of comment on it. So we have, we're working out basically our bounds here, like our x0, x1, y0, y1, our 4 corner pins for what area of the level we want to actually render. And then it looks like we just rendered the tile. That's it. So that's interesting because then we have all this other stuff that looks like the same thing, but it's not really. So get tiles. Okay, so just as a little test, let's just put in if true return, and I'll just put it on the same line, just to see what actually this renders. Okay, so it looks like we get, okay, so it looks like we don't get the animated tiles, so the water, or unless that's a different level. What level is this? I think this is the island one. And we don't get any kind of lighting, and we don't get the trees. So this first thing looks like it just kind of renders static tiles and not lighting. So that's weird because I guess that would imply that light tiles get rendered on top of this. Oh, and you can see torches aren't rendered either. So if we do the next block, nothing should happen, right? Because all we're doing is we're adding tiles to lists here. There's 3 lists it looks like: light tiles, post render, and treetops. So I guess this is where we actually render the light tiles. So if I go back here, you can see that we get the actual, and it looks like I'm stuck somewhere. Oh, that's a bit weird. That's weird. Oh, here we go. Wait, maybe that was a different level. No, hang on. Yeah, that was a different level. Why is this so slow? Oh, because we're not clearing it. Okay. Let's clear that. Should be a lot faster. There we go. Okay, so anyway, this is the, okay, so it looks like animated tiles are actually in this list. Yeah, that was my bad. I thought we were in this level. Anyway, so this has got 3. That'll be our reference. These 3 rocks. So we have, yeah, a bunch of tiles here, or a bunch of lights here, and you can see the light tiles are indeed rendering correctly and everything's fine. Our post render consists of, which by the way, we are adding a ton of. Let me just, I guess we'll move this up here. So we have post render, which is basically things that I guess get rendered on top of the ground. So stuff like trees and possibly torches. Yes, torches as well. And then of course we have, and I guess I'll just leave this code here because it's fine anyway. And then we have the entities being rendered, such as the player and stuff. And then we have the treetops being rendered. Now, of course, the treetops are rendered after the entities so that we get this kind of, we can delete this now. So that we get this kind of obstruction effect where the player can move behind the tree, right? That's why, that's how that works. We just simply render all the treetops, which are these things, right? We simply render them after we render the entities and the player and stuff. Brilliant. So that's how that works. Pretty simple. So of course, the thing that we're interested in is actual light tiles, not only the actual rendering of the light tiles, but also how we calculate whether we need light tiles. And of course, this is not efficient code by any means. I mean, we are creating a lot of data here, but looks like if a tile is an instance of a torch tile, that is when we need to add, looks like, light tiles. So, oh, this is interesting. And possibly wrong. Oh, no. Hang on. Oh, right. No, sorry, I misread that. Whoa, okay, that's interesting. So how's that? Okay, so it looks like, okay. Right. So this is the same as our loop, except we actually go, it looks like we go 3 tiles, 3 tiles extra. So we expand our like visible area like by 3 tiles in each way, which is why we have the -3 and the +3. And that, I guess, is just so that things don't... Oh, no, I know why. That's because of the lighting. Because, of course... Yeah, I remember now. That's because of the lighting. Because, of course, even if the torch is not visible, you can see coincidentally that 3 tiles happens to be the max distance of a torch. Yeah? Otherwise, if we set this to like 2, for example, let's just experiment with that. Then you can see that last chunk disappears, yeah? That's why we want it to be 3, so that we can kind of go all the way to the torch and then get the value for that. So that's why that's set to like 3 on each side. I mean, I don't know whether or not we needed the actual treetops and stuff to be in this for loop, probably not, but it is what it is. Okay, so this is the first thing we do. We create a light tile. So what is a light tile? So a light tile is, it looks like it is simply a coordinate, which also has a tile object in it. And every time we create one of these, we add it to a static list that is actually located in the light tile class, which contains all of the light tiles. Okay, so pretty straightforward, pretty normal. Like there's nothing really like wrong with that approach or anything so far. And that's all we do. So by the time we finish this, we should have an appropriate number of light tiles. So let's see, for example, after this, oh, well, I should probably stop it when we actually get into a decent spot. Okay, that's a lot of lighting. Okay, so there's one like there. So let's just stop that. So how many light tiles do we have? 1. Okay, so it's interesting. So that's interesting, right? So it looks like whenever we have a torch, as you can see, well, I mean, you could have read the code probably and guessed, but every time we, excuse me, every time we have a torch, we actually add a new light tile in like X and Y being, of course, the torch's current location. Yeah. So every torch on the map, not every torch on the map, every torch on the map that's visible in the current viewport, right? So that's visible to the player, or is within 3 units outside of the visible area. Okay. All of those torches, we take their position and we create a light tile at that position. Okay. And that's it. So that's how that works. That's it. So now what we have is basically inside this light tiles array list, we just have a bunch of light tiles, 1 for each torch, okay, that we can see, or whose light we are supposed to see because it's within 3 units outside of the viewport. Okay, so that's what happens. And then what we do is we go ahead and render all of the actual light tiles, which I guess, and we're about to look at that obviously, but I guess what that does is just goes through each of those torch tiles and then just, I don't know, renders another tile on top of our existing tiles with a varying brightness or something. We'll see what happens. Parameters that we pass into it seem to be, this is weird as well. We pass in the X and the Y. Oh, is that because render is a... No, that's weird. Okay, so this is like, for example, passing this in is completely unnecessary since, of course, it's located in the light tile class. But we do it anyway. Screen we pass in, and we also pass in the level object, which is interesting. So X and Y again are just equal to this. So we could have just used these. I don't know why I decided to pass them in. I guess I wanted to be consistent, or I was rushing because every other render function, like, I mean, the render functions inside tiles, so we'll go to like torch tile or something. You can see that those render functions do take in an X and a Y. Even though this one didn't have to. So I guess I did it there as well. But usually since tiles are just kind of, you know, flower tile, like tiles, since we don't have a separate instance of the tile class for each tile, we just have like one instance. We of course need to provide it, we need to tell it where we want it to render in this case, because there isn't, like a tile doesn't know, usually that's wrong, okay? Because you can see it, like as in we don't need this. This is probably isn't used at all. Because you can see that we create tiles statically, yeah? Which means there's one instance of each tile rather than having one instance for each tile, like as in there's one instance for each tile type instead of having one instance for each tile on the map, which would be very slow. You don't want to do that. But for torches, I think I did do that. Maybe I didn't. I don't know, because this is very confusing. As again, we just got public int x, y in random places, even though it's never used. So that's a bit, I guess that's just typical Ludum Dare. But anyway, this is the meat of the code, of course. So we get the current level brightness. This is important because this is the ambient light, essentially. Okay? I call it TB. Now, I don't know what TB stands for. Something brightness, maybe. Target brightness? I don't know. Anyway, we basically clamp the target, I won't call it that because I don't know what it is. We clamp the brightness to be between -240 and 0. So it's always going to be a negative number. It's one thing we should keep in mind. Okay, and then we go, and this is all in terms of tile kind of spacing, right? As in, like, we're not dealing with pixels here at all. These X and Y that gets provided to us, I believe, are in terms of tile coordinates. So these are tile coordinates, not like pixel coordinates. Okay, so then we go through basically an area here that is exactly 6 by 6 tiles, right? No, we go through an area that's 7 by 7 tiles because we count 0, of course, and then we go all the way up to 3, including 3. So we go from -3 to +3 inclusive, so it's a total of 7 tiles, and of course that is what generates this grid. You can see that we have 7 tiles here, 1, 2, 3, 4, 5, 6, 7, and 7 tiles across here. So that's what that for loop, this nested for loop right here, like the first 2 levels, don't worry about the 3rd level yet. That nested for loop is literally just going through this 2-dimensional area here. Okay, that's it. Starting from the top left corner. Yes, starting from the top left corner, and then of course going, looks like row by row until we get to this. Okay, now then, once we're inside a tile, so what this is used for is basically, let's just say, so the first iteration, we would be looking at this tile over here. So we look at that tile over there, which we iterate through it 4 times for some reason, with slightly, what is this code? Okay, so let's see what we do here. So we multiply x by 16. So we convert x into pixels, from tiles into pixels, since each tile is 16 by 16 pixels. Okay, so we generate a value that is between -1 and 1. I believe that will give us -1 to 1. Either -1 or +1. No. 1, 2. Oh, okay. This will give us either 0 or -1. If I'm correct, but no, we multiply by 2. Hang on. I'm confused now. I've confused myself. 2, -1. 2 gets to 1, 0 gets to... No, that should be... But that should either give us -1 or 1, so we're basically just deciding whether or not something will be positive or not. Then we multiply by 7, which is about half the size of a tile, if you start from 0. Okay. And then we divide it by 16 again. That is nuts. That is odd code. It looks like we kind of... That is weird. Why am I doing that? Wow, what on earth is that for? So it looks like what we're trying to do is like get... I just don't understand this times 7 thing. It looks like we're on this tile and then we're going a little bit to the left on the first iteration there, but like to half of this tile or something. And then of course we're dividing it by 16, which would round it down because it's an integer division, and then we try and get that tile. Why did I write it that way though? That's very weird. So what this does is it gets the 4 adjacent tiles in a diamond. So if we start our first iteration, we said we start off with this tile. What this code should do, I expect what it will do, I don't know why it's written like this, God knows, but it's gonna get this tile, this, basically, if we're here, right, it's gonna get that tile, that tile, that tile, and that tile. So the 4 adjacent tiles that are not diagonally adjacent, this will not get diagonally adjacent tiles. Or will it? I don't think it will. 0. So that should be -1, -1. Oh, no, hang on. I might be completely wrong here. Maybe it'll get the 4 corners. What? If I could go back in time, I would slap myself for writing this monstrosity. This is ridiculous. I think it actually might give us -1, -1, -1, -1 the first time, 1, -1 the second time, -1, 1 the third time, and 1, 1 the second time, or the fourth time, or the third time. Let's see. That's my prediction. So it should be maybe something along the lines of that. I actually think it might be that. But again, I'm just, let's just see. Oh, well, yeah, I mean, it takes x in compared to x. So I guess we'll do minus x minus y. Okay. Okay. So I was wrong about the right bound, but the left bound seems okay. So we get 0, -1. Okay, so I was right. Oh, but then that, why don't we have that? What is this? This is, I don't think this is correct. I mean, I don't know what this is doing. Let's actually read. Yeah, then it retrieves the tile. And what's the tile used for? Run the light. So weird. So weird. Welcome to live videos. No idea what this is. This doesn't make any sense. We even do 0, 0. What? Wait, what's XX? Ah, XT plus XX. What? Hang on. Let's do this. Maybe this will clarify something. Maybe not. Okay, so this looks like potentially one light here. Maybe we should find an area that only has one light. Like this. That's only got one light, right? There's nothing else around? Whoa. Oh, but hang on, but it's doing it for each of the tiles. Yeah, okay, that makes more sense. Oh, why does it do that? Do we need, like, why? Why can't we just do, like, because I guess we're trying to get the current tile, but I don't understand. Let me try something. This is, I actually don't get why this, like, why this is the way it is. No clue. Let's try some, I just want to see why this wasn't an approach that was possible, because this seems like extremely incorrect, especially because you can see that we reassign tile 4 times. Like, why would this not have been acceptable? Is that any different? No, that's identical. Is it? Or is that a little bit different? I don't understand why it would be different. It should be identical. Or is that, what is it? Because I'm seeing like this thing that I can't actually see over here. Oh, maybe that's because I'm a bit too high. That's what it was. Yeah, that's definitely there. Okay, so it's identical. Man, I don't know. I don't know what this crazy code is. And I don't know why my maths is wrong. Let's quickly go through the maths of this, just so that I can validate it. So I mod 2. When I is 0, this is going to result in 0. We multiply 2 by 0, so we get 0 and we get -1. That's how we get the -1 bound. Okay? And then for y on that case, I divided by 2, 0 divided by 2, of course, it gives us the same result. So we do definitely get that the first time. The second time, when I is 1, we should get 1. 1 times 2 is 2, minus 1 is positive 1, which is why I wrote that. And then I divided by 2, so 1 divided by 2 is going to round down to 0, times 2 minus 1 is going to be negative 1, so we get that. When I is 2, we go back to this being the same as what it was before, which was negative 1. This, on the other hand, is 2 divided by 2, which is 1, times 2, which is 2, minus 1, which is 1, which is why we get that. And then when I is 3, 3 mod 2 is 1, times 2 is 2, minus 1 is 1. So we get that. And then, so my maths is right. And then 3 divided by 2 rounds down to 1, times 2, which is 2, minus 1, which is positive 1. So that maths is correct. Okay, anyway, I don't know, man. I'm actually just going to delete this because it's upsetting me and it's incorrect. Furthermore, this does not need to be an actual thing. Okay, I promised I wouldn't change any code, but it's upset me enough that I have changed the code. Anyway, and I assume that that is indeed doing the correct thing. Yeah, yes, it's in tile precision rather than pixel precision. All right, so we're at what, 30 minutes? Incredible. Okay, doesn't matter, we'll keep going. That just took me way too long, but again, it makes it like, I'm glad that it wasn't just me not understanding. I think that code was actually just alien code that someone, like, I don't know. I actually, if anyone can find the point in the live stream, I think it's on this channel, at which I actually wrote that code and just like send me a link to that, I would be very, very grateful, because I want to know what I was saying when I was writing that code. Anyway. Okay, so the next thing we do is we basically grab that offset, of course, and find the pixel that we need to find. This R thing, which I'm assuming stands for radius, will basically calculate, so we multiply where we are by pi, then square it. So we're basically doing pi r squared. And then looks like we're, this is fun. Oh, okay, yeah. And then okay, sure. Okay, so let's get rid of the ABS, because anything squared is gonna give us a positive value anyway. So that's step 1. Okay. Or was that an extra abs? I don't know, doesn't matter. This is definitely gonna be positive. And I just want to verify I didn't break any of the bracket orders or anything. Okay, so that's all we're doing. So, but that's, yeah, okay. Yeah, sure, fine. So what this should technically do is give us a distance away from the light source. Or rather, I should say, it should give us oh, but not really. Yeah, okay. I can kind of see where this is coming from. Very weird code. Essentially what this is going to do is, I mean, you can picture it as kind of, it's a circular radius around, let me just get like red. So essentially what it's supposed to do is basically figure out which kind of ring we're in, okay, based on where we are in the for loop. So obviously if we're in -3, -3, we fall into this outer ring. Otherwise, if we're -2, -2, we're in the inner ring or the middle ring, and then -1, -1 here, and then of course 0 is just going to be in there, right? So it's kind of figuring out where we are there, which is an interesting value. However, the value we get here is going to be, I mean, it's going to be a decreasing value, but it's also going to be random, in the sense that you can see that we have, like, we start off with a large value like 128, then we get to the middle ring, which is 78, then we get to the third ring in, which is almost the target ring, and then we get to the last ring. Okay, so it's like the values, as you can see, are very random, as in, like, they'll always be that, actually, so they're not really random, but again, they're kind of useless to us. They're just like some arbitrary value. It might have been smarter to actually map this to a certain range, because all we really need to know is, like, hey, this means like we're 4 units away, this means we're 3 units away, this means we're 2 units away, this means we're 1 unit away, or something like that. So it's a little bit interesting as to how that works. But yeah, that's just how I've written it. Of course, this will be done for each tile, you have to remember. So I guess it is a little bit more than figuring out which ring we're necessarily in. Because if we're, it's also, yes, I should say, it's also figuring out yeah, because what this will do is it'll actually, it'll end up yielding that to be further than that, I guess, because if you look at what value this would be -3, 0, right? And then this, on the other hand, would be -3, 1, or -3, -1, right? Which, if you were to, you know, do this maths, and we can do that right now, I mean, we'll ignore the pi, because we really don't need the pi. I don't know why I've used the pi. Maybe I was like, oh, you know, circles, radius, radii, let's stick a pi in there. But anyway, don't really need a pi here. So we'll ignore the pi. But if we take a look at this maths, this of course will give us 3 squared, which is 9, plus 0, because it's 0 squared. And this will give us 3 squared, which is 9, plus 1 squared, which is 1. So this will basically give us a value of 10, this tile. This value will have a value of 9. So you can see that it's a smaller value because it's basically closer. That's kind of like how we figure it out. Because of course, if you look at this whole grid that we've kind of made up, what we end up having is, you know, I mean, 0, 0 being the middle, and then anything out here is going to be like, you know, I mean, this tile here is -3, -3, which is the max value, which of course will be 9 plus 9, which is 18, which is why it's so dim. So in a way, this R value for each tile in our grid will figure out how far away it is from the origin by using... Oh, and we square it. Why do we... Oh, I don't even know. Maybe I was halfway through like Pythagoras theorem or something, and then I just decided this would be enough or something. But literally all we had to do, and I guess the squaring is kind of okay. I don't know. Honestly, it's not too bad. I would probably get rid of the pi though. Anyway, in fact, I'm just thinking, honestly, what we could have done is just probably added the numbers together in an absolute fashion. So just math like ABS, both values, and then just added them together. And then that would give you enough data, I think. But anyway, I haven't done that. So then we work out this weird intensity thing. So we have this radius, which again is the distance of the current tile from the origin, which is the 0, 0 tile, which is the middle. We multiply it by the level brightness, okay? And then we multiply it by 0.00012. Very specific, okay? I probably spent like an hour tuning that value, or like a few minutes at least. And I can assure you that's completely random. So basically what this should do is give us an intensity factor. If you look at what this is, I mean, let's see what this is. And of course you can see it's being multiplied by the level brightness as well, which is why it's like didn't kick in until now. You can see it's basically a value between, it's always a negative value, keep in mind, because this level brightness is always negative. So it's always going to be a negative value. Looks like between roughly -4 or so and 0. Okay, it's never going to be positive. Okay, so then we take that we take that negative value, which is our intensity, and then we pass it into screen render light, only if the radius is less than 100. So if what that will do in practice is basically eliminate these corner tiles. So you can see that's why it almost looks like this is kind of a circle, because these tiles are too far away to actually be here. Even though they're in our grid, so where like this for loop is covering them, they're too far away based on this maths, based on this radius. And so because of that, they don't get any lighting applied to them, okay? And that's how you kind of, otherwise you would get like a grid, which we don't want. Okay, and then screen render light takes an intensity, which keep in mind is a negative value. It takes in a color as well. And then with that intensity, we tint, it seems. Okay, and then we call color.tint. Okay, I see. So I am really confused as to why that's negative, but we'll ignore that, I guess. It is weird, isn't it? And then we have this subtle value. I guess okay, first of all, we've determined that RGB is actually the other way around. So that's like RGB, I think, or something like that. We covered that in a previous episode. And also, we've also kind of determined that the way that we do this is we basically grab the original color of the tile that we're about to render, and then we scale, which is weird, isn't it? Because I mean, we are like, that should be the red channel. I don't know, it's all weird. And oh, but we give it a negative value. That's probably why. I think that might be a bug as well. Let's just take a look at this. So intensity will probably be 0. Yeah, let's wait a little bit till it kind of gets dark. Okay, that's dark. Intensity is -1. R is 62. Okay, so weird. So we get the red channel from this, 87. We get the green channel from this, 165. We get the blue channel, so it looks like we're rendering a grass tile. This is going for every pixel, by the way. And then so we've reduced the red channel, the green channel, and the blue channel. And then we clamp it, so it's acceptable. And we return the value. And so that's what our color is now. So we've basically reduced our color and brightness, it would seem. In the render light function, we've reduced our brightness. Okay. Let's go through another iteration real quick. So our color used to be 87, 165, and 95, and now it's 13, 89, and 18. And that's called rendering light. Oh. No, I know why. That's because that's an outer thing. Let's go back into light tile. Yeah, so what we want to do is we want to just hit resume. And then what's XX and YY? -1, 2. So let's just give it a minute. So -1, -1. I guess should be brighter. Keep in mind though, that it actually might always be reducing brightness, and that might make sense. So this brightness reduction should be a lot better. As in, like, it should be a lot, like, it shouldn't reduce as much light. So if we have the same values, 87, we can see them up here. 87, 165, 95. And now there, so you can see that that was a very kind of small reduction in thingy. Because you have to remember that the original tile is actually very, very dark, because the level, like the level brightness has been applied to all the other tiles. And so what this is doing is it still has to dim it a little bit. It's just that it obviously dims it a lot less based on where it is. So that's it. I mean, that's all there is to this lighting. We'll cover mob lighting and like entity lighting next time, because we're way over time. This is like, I mean, we're at like 42 minutes, which is what, like a normal episode of like a TV show, like a drama series. So, that's my cue to end this. But basically, I mean, that's how it works. It's actually really simple. Obviously, I was telling you guys this from the beginning. Now I know how it works, which is good. So just to summarize this last part, for each of the kind of a grid of what is it, 7 by, wow, 49 tiles, really? No, that can't be right, really? Hang on. Where's my paint thing? Yeah, wow, okay. So in a grid of 49 tiles, which is a lot. Yeah, okay. So in our grid here of 49 tiles, we go through each tile, we basically give it an intensity, which is how much reduction we want from the original sprite, which is obviously bright, as if it's like fully lit by daylight. So we calculate an intensity being not an intensity to add light, but rather how much light to subtract, or how much brightness to subtract from the original source sprite. Okay, and of course, calculating that is based on its position in our grid. And then finally, if the radius, if the tile is lit at all, then we apply this render light thing, which renders another tile on top of the original dark tile, which is like this color because it's night, with less reduction in brightness than the original ground tile would have had. Okay, and that's how we get our lighting. Okay, so it's a little bit interesting. I would have done it very differently if I did it today. I guess partly the thing that I would have done would have been maybe not render the tile twice, maybe actually just while you render the tile, quickly calculate whether or not it's in the light. So in the original rendering pass is when I would have applied the light, instead of doing it this way, which is a little bit weird. But sure, this works, I guess. And it's almost like a post effect. It's almost like a post-process kind of effect that this thing is, because of course it's being applied to the original image, but it's not like it's being applied. It's like the tile is actually being opaquely re-rendered on top. So it's a bit weird. But of course that has nothing to do with mob lighting, which we'll look at next time, as to why like certain mobs are not actually lit correctly. But in terms of this, you can see that's the way it works. Now, the other question is, why on earth do multiple tiles that are in light actually, or like we were talking about like whether or not it was a multiplication kind of factor, or whether it was an addition, like as in how were two lights actually communicating. And it turns out the way that two lights add up is they don't. It just takes one of the lights. Because of course what this will do is just overwrite. Like it'll just render on like an additional tile on top. So whatever light happens to get rendered last, that's what you will see if two lights cross. So that's the answer to that. Anyway, guys, thanks for watching this video. Hope you enjoyed. If you did, please hit the like button. Now, I always forget to mention this. Well, I don't, but I never have it up automatically. But if you guys want to follow me on Twitter, like social media wise, the best place to follow me to stay up to date with all this stuff and know when I'm putting out videos and stuff is going to be twitter.com/the Cherno. If you are interested in my life, which most of you I know passionately are, then you're going to want to also follow me on Instagram, because I mean I've been like taking just photos pretty much daily and just posting a lot of stuff. So Instagram.com/the Cherno is very, very active. So if you just can't get, if one video per week, which is what I'm doing right now, is just not enough for you guys, then this is like the best place right now to interact with me and to see what I'm up to, because I've been Instagramming a lot lately. All right. But anyway, I'll see you guys next week. I don't know if I'll put out a game programming episode or this episode. I might start alternating. So 1 week Genesis, 1 week game programming. And we'll see what you guys think. We'll see what the response to this video will be like. I mean, if it's a lot, because game programming I think is dying down a little bit, which is why if you guys actually enjoy this video, you need to hit the like button, because that's literally how I decide what kind of video to make. I look at the likes and I see, okay, this one has 70 likes, this one has 200. I'm going to probably make the one that has 200, right? Makes sense? So that's how I roll. Anyway, see you guys next time. Goodbye. Form.